I'm really stoked for this. So, as part of the Improving RAG sort of series that I've been hosting, I've been really excited to be able to bring together a bunch of folks building the code generation space. I think it's probably one of the most like economically viable forms of agentic RAG. And basically, my belief is that the things we learn from you are the things we'll be able to apply in the future to general document search, internal tooling, like everything else that's RAG related. I think coding systems would probably will give us a glimpse of what that looks like. And this is really interesting because a lot of the systems I've been seeing get built these days do fall victim to the chat style of RAG. A
Mhm.
user makes a search, we do embeddings, we shove things into context, and we hope it works. But as workflows get really complicated, we have to do things like reading and planning and searching and subsequent tool calls. And so for all of us listening here, I'm really excited to bring in Beyang Liu as CTO of Sourcegraph and the creator of this new coding agent, AMP. It's a tool that I've been using a lot in a couple of weeks. And the idea that they're really going to explore is the fact that we've replaced things like vector databases with grep. We've replaced many sort of search indices with just having better feedback loops and context sources. And I'm really excited for you to share more about the principles that you have, how you think about the portfolio of tools and sub-agents to build out this larger LLM system. With that, yeah, the floor is yours.
Thanks, Jason, for the introduction, for having me. Hello, everyone. My name is Beyang, CTO, co-founder of a company called Sourcegraph. As Jason mentioned, we're building a coding agent from the ground up, and the agent's called AMP. And as part of doing that, we basically started at first to question a lot of the principles and best practices that we had learned from building our previous coding assistant, Cody, which is one of the first sort of like RAG-oriented AI coding assistants on the market. And at some point, we took a step back and said, like, actually, there's so many things that have changed that maybe it's warranted to actually like rethink everything from first principles. So that's what this talk is kind of about. Okay, so why rethink things from first principles? I think at a high level, it's for this reason. If you look at the evolution of AI, and specifically what we now call Gen AI, I would argue that it's actually been through at least three distinct phases or eras. The first era was the autocomplete era, where the predominant model at the time was GPT-3, and the predominant application architecture was autocomplete, because that's what the underlying model was capable of, and so that's what you did as an application builder. Next came the sort of like RAG chat era. This was ushered in by the release of ChatGPT and GPT 3.5 and then GPT-4. And this era, moved beyond basic text completion to the point where you could actually instruct models to do certain things, like generating a piece of code, following instructions, or asking a question about a code base. And the key inside of this era was like, hey, the LLMs get a lot better about reasoning about facts if you actually hand them factual things, so that they are completely reliant on what they've memorized from the training data. And that sort of era culminated in what I like to call the emergence of like the VS Code forks or the AI IDEs. This was thick clients that were built to deploy chat LLMs in various situations that really worked around a lot of the limitations of chat LLMs of that era. And the era that we're entering in now, or have entered in with, I would say like 3.7 Sonnet, now Claude 4, is the era of agents. And so essentially like a new training technique has yielded a new type of model, and that in turn motivates a new application user experience and architecture. And so what is that architecture? In short, the architecture has changed once again. So in moving from the RagChat era to the agentic era, the main thing in this diagram is the inversion of the context fetching step. So in the RagBot era, all AI applications kind of followed the same basic pattern. You had a user message, and then before forwarding that user message to the LLM, you'd first have your kind of like monolithic context engine go and fetch relevant snippets and pieces of information from different sources, and then take those snippets and place those within the context window of the LLM and have it generate a response. With agents, the control is now inverted. So instead of having the RAG engine decide what is the relevant context and then handing that to the LLM, you now have the model decide, based on the user request, what tools do I want to invoke in order to fetch the appropriate context. And it seems like maybe like a minor change, like in the picture, just moving the green box down to the bottom. but it actually has some pretty big implications for what the user experience is and what the architecture is, in our view. Okay, so what is that? What are the implications of this change? So the coding agent that we're building is AMP, and I like to show off AMP as basically just like these are screenshots of what AMP is. These are the two clients that are what users of AMP use. So there's a simple VS Code extension. It's very bare bones. The main input is just that text box. And then you have a CLI, which is also very bare bones as well. And the thing I want to call out here is just how simple these interfaces are, in contrast to a lot of the kind of like context tagging UIs that were built for the sort of like chat LLM era. And in building AMP, I think we made what are some controversial design decisions if you're coming from the world of chat LLMs, but even if you're building agents. So you already saw the UI, it's very minimal. We're really focusing on the design of the agentic feedback loops rather than a complex graphical user interface for selecting context. When we designed AMP's interaction, we bias more towards just having it do things. So when it edits files for you, it normally just doesn't ask before editing a file. It does ask before executing some bash commands because those can be destructive, but as much as we can, we try to make it so that the human doesn't have to micromanage what the agent is doing, which is a big departure from the chat LLM paradigm of like, every kind of turn of the LLM, the human is sort of like guiding and nudging and modifying the output. Third, there's no model selector. So, in contrast to a lot of the other agents you see out there and a lot of the AI tools from the previous era, we didn't build in a kind of like model selector into the agent. And I'll talk a little bit more about why that is later. And then we also believe in more of like a Unix philosophy rather than a thick client that's like vertically integrated. It's easier to compose and combine with different things. And then the last thing, which is not a technical thing, but just an economic thing, I think more and more people are starting to realize that in the era of agents, because token consumption is so high, if you have flat pricing, it introduces quite perverse incentives on the behalf of the product builder. So if I'm charging you a flat price, but the cost that I'm incurring on the back end is variable, then I have a strong incentive as the product builder to kind of like nerf or dumb down the intelligence of the models I'm using to make the cost fit underneath that. And so we're kind of throwing that out because we want to build the tool that sort of like maximizes the intelligence. So this is kind of like a sales pitch slide, but it's just motivating, like, why do you care? These are controversial design decisions that we're kind of doing differently from a lot of other folks. And so, why are we off our rocker, or is there something to it? I think we've seen a lot of good feedback from people just saying positive things. That's like the left-hand column, but also comparing us favorably against AI IDEs in terms of what the agents do, how far it's able to get, and even against other agents. So there's design decisions that are baked in here that I think have made AMP just do better or feel better than some of the other coding agents on the market. And a lot of that ties back to our approach to doing, RAG for the agent. Okay, so let's talk about that architecture and the design of that RAG engine. So before we get into that, what motivates this differing architecture? It's really a shift in the kind of like user interaction paradigm. So like the dominant interaction paradigm of the chat world, the human was very, very much in the inner loop of interacting with the model. Basically, like every LLM turn, you had a human checking output. You say like, write a function that does X, and then it would generate some code, and you're like, not quite like that, more like Y. You'd refine it, and then once you were happy with the change, you'd say, okay, now take this change and apply it back to my file. Go edit the file and apply that change. And so you'd have a lot of ping pongs with the model back and forth just to make one sort of like atomic change. In the agentic world, it's now possible just to articulate what you want up front, have the agent do a lot of work, a lot of validation on its own, reading the file, editing files, searching around for related files, executing bash commands, checking compiler output. And so it's able to get much further. And with the proper prompting, we've seen much stronger success with it just being able to cut down on the ping pong and just do the thing that you want to do. So you can not have to babysit it and also get things done much more quickly. So this interaction paradigm shift motivates an architectural shift. So if you look at the architecture of, RAG chatbots, most of them had a pretty thick client and also a pretty thick and monolithic context engine. And that's because of two things. One is the context engine was doing a lot in this case. It had to kind of basically fetch relevant context snippets for all types of user queries. And using that, it would then place those relevant snippets into the context of the chat LLM. The coupling of the context engine in the chat LLM was also fairly loose. That's why you saw a lot of people ship model selectors that allow you to kind of interchange the model in use. And then lastly, you did have a pretty thick, complex UI for a lot of these applications because the monolithic context engine couldn't always magically infer what was the relevant stuff to fetch. And so you had a fallback for humans to be able to kind of ergonomically tag in the appropriate bits of context. Now in the agent world, the combination of a tool use model with a proper set of tools is able to essentially replace a lot of the intelligence that the context engine previously had to provide. So really the core of the logic is more in these agentic feedback loops and how you design the runtime and how you tie together agents with different subagents and how they connect with tools. That is a much bigger part of the kind of application development paradigm. And so you need a thinner client because there's not as much human intervention. And you also need a far less monolithic context engine. In fact, you can kind of decompose that context engine into a set of smaller, more primitive tools. And then it's really all about the coupling between the tool use LLM and that set of tools and how it's able to take advantage of those tools to get further and further successfully. So, if you look at the RAG engine set of features for the chat LLM era, you had, typically this is probably the median RAG engine, right? You had a basic, keyword index BM25. Then you trained an embeddings model. You probably fine-tuned that on your domain-specific data to get it to perform better. You probably had domain-specific chunker of some sort to be able to do document chunking in a way that made sense. And then on top of all that, you slap a re-ranker to basically, aggregate results from these lower level retrieval mechanisms and then re-rank them properly. Maybe you have some intent detection at the very top to route between different kind of re-ranking engines because you have different types of queries. We built all of this for the previous era of coding assistants. And then it's you look at some of the most popular agents on the market today and what's the main tool they use? It's grep. That's an oversimplification. I think now you're starting to see more retrieval tools being leveraged by agents as well. But the fact of the matter is a basic agent that uses a very simple retrieval tool can match the performance of some of the very fancy monolithic RAG engines plus chat LLMs in the previous era. And so if you want to see this in action yourself, there's a blog post that a member of our team wrote called "How to Build an Agent." If you want to do it yourself, just read the blog post and follow the instructions. But you can also have an agent just read through the blog post and generate an agent yourself. It'll create a very simple agent with a very simple set of tools. But it gives you something to play around with and see, even with a simple kind of 101 basic version of an agent, these things are pretty intelligent and pretty smart. Okay, so I basically just said, RAG as you know it is dead in our opinion. So what does RAG look like in the era of agents? In our view, it's really about three main categories of considerations. So number one is what sort of tools do you give the agent? And so you have tools in the retrieval sense, where some of the tools are about retrieving the relevant context. But there's other forms of tools that also are becoming more important. And so if you take a step back, what was the motivation for RAG in the first place? It was really just to get the models to be able to do more things for you in kind of productivity-oriented environments. And so one of the things we say is that RAG is not strictly about retrieval anymore. It's really about just molding the underlying model to be able to do what you needed to do in a particular application setting or for a specific set of workflows. And so the tools, I like to categorize them as breaking down to like three main things. One is just context retrieval. That's more the sort of like traditional RAG sense. The other, the second point is like feedback. So how do you get more feedback about, what the agent has done? And then planning to structure agentic flows over a kind of like a longer period of time. The second main category of consideration for agents is really about context window management. And so as we try to stretch agents to do longer and longer chains of automation, the context window size sort of emerges as kind of like a key constraint. And so, what do you do to ensure that the context window remains focused, the model doesn't get confused? How do you avoid tool overload? Do you do compaction or something like that so that you can kind of like continue on past the limits of some of these context windows? And then the fourth point is I think the emerging as like the most important point for us at least is the use of subagents as a mechanism to effectively conserve or extend the context window of the main agent. And then last but not least, it's the model choice is really important here. And I would emphasize again the point that like we've kind of gone past the era in our view of being model agnostic because there's much tighter coupling between models and set of tools now. You really have to be intentional about the model that you use for any particular agent or sub-agent. And so just to dive into a few concrete examples here. So if you look at the construction of the tool set for AMP, on the right-hand side, that's the tool panel for AMP. And so the way to think about this is at the bottom, you have your list of tool providers. These are external services or packages that will provide a suite of tools. And then at the top, you have all the tools that each provider provides. And so if you look at the main tools that AMP uses to fetch context, it's really a kind of like a suite of I don't want to say simple tools because some of these things actually do a lot underneath the hood, but they're far simpler and less monolithic than your kind of like standard chat-based RAG engine. So grep and glob, those are great command line tools. We also have a search sub-agent that stitches together some of those primitive tools into more of like an agentic flow where it will do multiple queries and refinement of queries in succession to find the right thing. It pulls from the web, documentation on the web, as well as pulling from specific services that might have relevant context about things that you're trying to do in your development environment. So it's really this like combination of tools. And then the reason why we separate out the kind of like tool provider interface from the tool selection interface is that what we found is one of the things that you want to avoid is kind of like tool overload. So one of the things that we've observed with the advent of things like the Model Context Protocol, MCP, MCP is great. It encouraged everyone and their mom in the world to think about how to make services ready for agentic consumption and how to package up the context that those services contain for use and consumption by agents. But naively just throwing in all the tools that an arbitrary MCP server defines, that's a great recipe for just confusing the heck out of the underlying model. Because again, that context window, you have a limited amount of context, and each piece of context that is thrown in there that isn't relevant to the task at hand ends up being a potential confounder for the model that might confuse it or make it make less intelligent choices down the road. Okay, so this is kind of like the set of tools here is sort of encompasses what would be known as kind of like traditional RAG, but for the AMP agent. But as I mentioned before, I think a really another very important element of kind of like augmented inference in the agent world is these feedback loops. So in addition to fetching context from other sources, you also have the context that is provided by the environment itself. So agents, unlike chat LLMs, they do things in the environment, right? Like they edit files, they execute code, and what that means is they can also execute things that verify whether they did the right thing or not. So like you could use bash to execute the unit tests and get feedback that way. A very popular MCP server is the Playwright MCP server that allows you to take screenshots, or I should say it allows the agent to take screenshots and iterate against what's in the screenshots. It's great for front-end development. especially when coupled with something like Storybook, which makes it easy to isolate specific UI components and go back and forth. There's the editor diagnostics, which is really just an easy way for the agent to consume compiler output. And then you have other services like Postgres. So, very popular MCP server for us is the Postgres server because we use Postgres on our backend. And so when it's making a change to the Postgres schema, in our case, you can actually go and inspect the schema in the dev environment based on what it did. So you have context, you have feedback loops, and then once you start stitching these things together, it's a natural tendency for users to want to get to kind of like longer and longer chains of automation. And so actually helping the model structure its actions over a longer horizon of things becomes more and more important. So we're moving way past the point where humans have to babysit every single model inference point, to the point where now instead of I think the ideal interaction is, instead of making it easy for the human to intervene, it's really about helping the user convey more of the context up front for the model to do the right thing. And then at the product layer, we've added this kind of like to-do mechanism. So this is kind of like the planning light product version of the more complex planning that people do. And so AMP will typically, when asked to do a more complex or non-autonomous task, it will add things to its to-do list so it can kind of like structure itself to avoid just like diving into the first rabbit hole it thinks of, and going down that rabbit hole and writing a lot of code that isn't useful. Okay, so that's a bunch about how we're doing context and planning. I think a lot of what we think about now in terms of stretching the capabilities of agents and LLMs is about extending the effective context window. And so you have things like compaction, which is basically saying like, okay, this interaction, this thread with the agent has extended to the point where it's now filling up the context window. Let me summarize the thread and then continue on from there. That, I mean, it is good. We do use that a lot, but that has its limits because compaction is sort of this like lossy process. And a lot of the times it's not clear to the model that's doing the summarization what are the important parts of the original thread. And so a much more intentional way to do that kind of like garbage collection of unused context is subagents. So AMP implements subagents in a couple different places. The very first subagent we implemented was actually this code-based search subagent. So oftentimes when you ask AMP to do something, it needs to look up context, and it can't get the context from simple invocations of grep or glob or other basic Unixy tools. It will actually invoke a subagent to go and poke around the files in the same way that a human might to find the right thing. And this is nice because all the exploration it does when it's like refining different queries, trying different things to find the thing that the user is looking for, that eats up context window. But because it's a subagent, once it's found the right the set of snippets and return them to the main agent, you can essentially like throw away the context that was used for the subagent. So the code-based search subagent often eats up a good portion of the context window, but it's not the context window of the main agent. So it doesn't prevent the main agent from taking the relevant snippets and doing more with that. In addition to the code-based search agent, which is a very specialized subagent, we also implement a generic subagent. So this is essentially just like recursion, but for agents, right? So AMP can effectively invoke itself to perform tasks in parallel. And we find that this is common in cases where you're trying to make one type of change in many instances, or do like one type of retrieval across many different cases. So this is sort of like a toy example. Just the other day, I was thinking to myself, like, yeah, I don't have much time to read Hacker News these days, but it'd be great to kind of like stay up to date with what's going on. AMP, let's just have you spawn a subagent to summarize every single like top post on the HN front page, produce a high quality summary, and then the main agent can gather all those artifacts together and summarize the key points. The same scatter gather approach can apply to unit test generation and a bunch of other things that are kind of like common in coding use cases. And then last but not least, the most recent subagent we've added is this subagent that we call the Oracle. And the reason we call it the Oracle is because it thinks really hard and is much better at getting to the right answer just by thinking. And this one is noteworthy because more and more we're playing around with the capabilities of combining different models intentionally in subagents. So, earlier I said that the model agnostic architecture is going away because it's hard to rip out like the main thinking model and replace it with some arbitrary other model. I think more and more you're going to see application architectures use models intentionally. So rather than having something that's like, very swappable, it's like, okay, you want a specific subagent to do a specific type of task. Hey, there's a model out there. In this case, we use O3 that's really good at this like nuanced thinking and teasing through tricky to understand code. Let's actually use that as part of the agent construction here, so we can take advantage of the abilities of that model without having to also adopt some of its weaknesses for things like tool use and sort of like agentic composition of those tools. Okay, so on the model selector, why do we think that that is now an anti-pattern? I think this probably goes against some of the things that you've heard from builders of other agents, but this is our kind of like salty take. And when we try to think about why it is we think the model selector ought to go away in the architecture of agents, it's really this. On the left-hand side is the basic loop of chat LLM-based AI applications. So this is like the loop of the quote-unquote ChatGPT wrapper, right? Like you have the human do something, then you go retrieve relevant snippets, you put it in the LLM. It's very simple, and there's not a lot of tight coupling between the retrieval mechanism and the model here. So it's quite easy to say like, oh, let me take the same relevant snippets and put it into, Kimi K2 or O3 rather than, Sonnet. And let's take a look at the results. And that is often something like that is kind of like cool and interesting for an end user to do. If you look at the flow in like an agent, though, it's much more complex. So like you have the human making requests. These are forwarded to the agent LLM. And then that LLM has a bunch of tools that it could use. And each tool description, it becomes part of the effective prompt that then is kind of like coupled with that LLM to get it to effectively determine, when to use or not use a tool. And then in addition to that, some of these tools are agents themselves with their own set of models that are kind of like tuned to that specific use case. And so if we were to offer up to end users a way to easily swap out any of these LLMs for another model that's not been tuned to those tool descriptions or has other kind of like tool use capabilities or characteristics, it's just a recipe for a bad user experience. And I think you've seen this now in a couple instances where like a new model is released and there's some other tool that integrates it into the model selector, and then the model provider gets mad. I think like Elon got mad the other day because he thought that another tool wasn't doing the latest release of Grok justice. And so for us, this is basically why we think the choice of model has to be much more intentional for building agents. One last thing that's kind of a little bit orthogonal to the whole discussion of RAG and technical architecture, but I do think that it's an exciting time to be building applications because number one, there's much more interesting application architectures that can be built on top of agentic LLMs. And two, from a user's point of view, I think agents are far more high ceiling tools than chat-based applications. So chat-based applications were always constrained by sort of like the retrieval engine model. And so the way to think about them is a lot of them were kind of like search plus plus. It's like get the search results and then generate an answer. And that's great. It can do a lot of things, but it doesn't yield a lot of, it can only go so far. Whereas with agents, you can actually prompt them to do much more complicated things, but you do have to get better at prompting to be able to do that. And so one of the things that we built into AMP is this built-in kind of collaboration mechanism where you can see all the threads that your teammates are having with the agent. So you can see like who's using the agent for which use cases, for what tools, how long are their threads, how do they prompt. I've learned so much just from like watching how other people on the team are doing prompts. There's some people who write like paragraph, like essay long prompts, and are able to get enough context in there to get the agent to do much more. And so I think the way to think about this, it's important to realize that as an application builder, the agent could be a much higher ceiling tool, and to ensure that you're not kind of like dumbing it down artificially just to make it seem, more magical for kind of like newbie users. Okay, so in short, like we think that it's really important to think from first principles when building agents. A lot of the best practices that people developed during the chat LLM era, I think, are no longer relevant at best, and in the worst case, actually, run in direct tension with what the emerging best practices for building agents are. And so, when I talk to other people building agents, I usually kind of bring up, three things, or three questions. First, it's like, what are you cargo culting from the chat LLM era? Have you actually, thought about whether that is the best construction for building an agent? Two, are you treating context not as a retrieval, not just as a retrieval exercise, but as this kind of like broader set of things that provide relevant information for the context window? And then three, are you thinking about how to unlock the ceiling of what agents can do? Because I think the potential here is far greater for them to be able to automate and accelerate much more of knowledge work. But it does require thinking about how you design intentionally for that, rather than, just how do I provide the smoothest ladder for newbie users into this product experience? Because often those two things run in tension too, like making it quick and easy for new users versus preserving the power of composition and the ability to do more complex things for your power users. So yeah, it's kind of like a whirlwind tour of a lot of the things we've been thinking about with AMP. Thank you all for listening, and I'll turn it back to Jason, who I think is going to take some questions now.
Sweet. Yeah. I mean, I think it's been clear that like the whole Sourcegraph team has thought pretty deeply about this kind of like code experience. Especially because I think you guys have such a rich history in thinking about code understanding. Um, which brings us to the first question, which everyone is curious about, which is for AMP, do you guys see a lot of use cases in the AST aware tools? I know recently, I think maybe today I saw that the tab model uses the LSP. I'm curious where you guys are thinking about this, because I used to wish I could have like code mod support for coding agents when I was doing like these massive refactors.
Yeah, so that's a very kind of like, the answer to that is, I guess it's complicated, but I'll try to condense it.
Sure.
I think what we've learned over time is the deployment of like static analysis tools and AST aware tools should be motivated by the shortcomings that you see in any particular use case. So it's not a good formula to say like, oh, I have this great thing that's like semantically aware or like is aware of types. Let me go and like bake that into the agent architecture straight away and make that a requirement. I think that is at this point just kind of like premature optimization or premature fanciness to a certain extent. Because LLMs are so new, the classic saying in machine learning is, like do the simple thing first, the brain dead simple thing first, establish a baseline, and then you can explore like fancier methods, fancier tools, and fancier capabilities to see if they actually move the needle. And so I think in certain cases, like the tab completion, being able to be aware of what imports you're pulling in turns out to be like pretty useful for improving the quality of predicting the next edit that the user is going to make. That's a case where those tools come in handy. For the main like AMP agent, it doesn't need to use any of those tools. You can plug them in, but we kept them out of the kind of like built-in set of tools because for a lot of languages, at least currently, they do not add that much value.
I see. Yeah, I will say if AMP ever considers going down to world of like code mods, I feel like every time I want the LLM to rename a function, it has to edit like 45 files.
Yeah.
Those have been a specific example where I've been thinking about like building a CLI to do some of these code mods for larger migrations. Do you feel like it's also about just like the bitter lesson? Like in the future, these LLMs will just know and it'll just have the awareness of the AST.
I think the bitter lesson comes down to is the thing that you're trying to do, can it be captured by data collection of
Yep.
some application that is currently being used by the people doing the work that you're trying to do? Or can it be emulated in some sort of like synthetic environment? And if the answer is yes, then um, the days of that approach are numbered. But you could still build it as a vehicle to generate the training data, right? Like compilers, static analysis tools, all these played an important role in generating the data that were used to tune these models to be able to make effective use of
Mhm.
tools in a coding setting.
Yeah. I mean, I think the other question people are really dying to think about is just sort of outside of the coding session, uh, coding setting, like how much of this do you feel like applies to, general, maybe like QA systems or report generation systems? I obviously have my own feelings about this, but I'm also curious,
Yeah.
do you guys use these like AI tools from other vendors and go, I wish they had sub agents. I hate this model picker. Um, how's
You
your
know,
experience been with that?
it's funny that you mentioned that. Like, because AMP has this like thread sharing capability, it's like trivially simple just to peek at what other people are using it for. And still like the dominant use cases for like coding and technical Q&A.
Mhm.
But like every now and then I'll see people being like, hey, can you do some research? I think I saw one thread the other day, which is like, my kitchen sink garbage disposal thing broke. Can you like search the internet for appropriate things and help me fix it? And so I think there is a lot that sort of like generalizes to other
Mhm.
use cases here, and you see people using that. I do think that there is some limit. So I think from what I've seen, the things that do generalize well are the things that kind of look like are the workflows that can be done using a set of tools that look more or less like the set of tools that you have access to in your development environment in your terminal. So like, basic search, basic code execution, basic retrieval of relevant documents. There's a
Mhm.
whole bunch of knowledge work that kind of falls under the umbrella of like, okay, like as long as you have some tools that look like that, you as the human can get it done, and therefore like the agent can probably do a pretty good job as well. I think there's other forms of knowledge work. Um, like I have a friend who's working on like a finance AI
Mhm.
who's building it to do more like fundamental sort of analysis. I think there's some tools and some forms of reasoning there that don't have like good mappings to the type of stuff that people do in the development environment, and so there it's a bit harder to generalize that.
Interesting. It's funny you say that because I just saw that Cloud Code announced Cloud Code for finance, but I guess it's a different kind of
Yeah,
analysis. It's really around like the portfolio of tools. So I
yeah,
think,
yeah. I think there's probably a lot of workflows within, finance is such a big umbrella. There's probably a good number of
yeah.
workflows that do fall under the umbrella, but for certain specific types of workflows,
Hmm.
and I think you will see this in every knowledge domain. It's like the workflows that can kind of be captured by the RL environment of the models. Those will start to be more and more automated. And then what's left, which is a tiny amount of the workflows right now, that will expand to being, the lion's share of what takes up people's time, because that's where
Absolutely.
the interesting alpha remains.
Yeah. That doesn't make sense. Even this idea of like, I guess I'm like curious about this question too. Like you mentioned that searching for the information is actually very context, expensive. And so we might kick off a agent. Does this sub agent sort of preserve the history of the main agent before it forks off? And like, does that sub agent also have more sophisticated tools? Or is it just also grep for the most part?
It has a different set of tools than the main agent. It does not inherit the context window of the main agent.
Hmm.
For that subagent in particular, we found that the existing context ended up being more confounding than
Hmm.
useful.
Hmm.
There are
Yeah.
other forms of subagents where that history can be more useful. So I would say that's like a hard and fast rule. It's really dependent on what the agent is trying to do.
Yeah, I imagine there's like a preserve history and sub-agent flag, and you just
Yeah.
do some experiments to figure out if it is better or worse. I'm curious then, it's like, how do you start evaluating things like this? In a lot of what I've been doing, maybe earlier last year, was we have a search tool. It is
Mhm.
retrieving text chunks. The text chunks are relevant or not relevant. So there is a recall metric. And if we
Yep.
can go from 68 to 72, we're doing better. Um, Now that agents are so persistent, well, if it's 62, it'll just take 9 more searches
Yeah.
and you get the same result. So how do you think about designing the tools versus the the result of the LLM capability?
Oh, I think you cut out for a little bit, but
Oh,
I got you at how do you think about designing the tools versus
Yeah, like improving and designing these specific tools versus the whole system, right?
Yeah, that's a really good question. I think it's a combination of trying the tool out in the product itself and seeing how
Hmm.
it feels, and then having evals to make sure that you're not regressing some other form of behavior.
Hmm.
Um, I do think that this concept of a tool provides pretty good encapsulation of like, hey, if you're trying to make it do something, you encapsulate with a tool, and then the decision is like whether you turn that tool on by default
Hmm.
or not. And that's much nicer than making it like all or nothing for every one of your users. That being said, you still have to be careful. And so I think of, like when you build a new tool, it really should be motivated by some like pain point that you felt as a personal user. And so it's like all new things, in my view, are motivated by like vibes, right? Like, that thing was painful. I want it to be better.
Yeah.
Um, you should never use evals as a way to kind of like guide your product development because evals are always kind of like downstream of the vibes. Like evals are in
Hmm.
some sense like an attempt to like quantify
Yeah.
the vibes. And so I think of evals more as kind of like unit tests or smoke tests for like, hey, these workflows currently work well. I want them to continue working well, even as I
Hmm.
make changes to make some of the things that don't work well better.
Yeah. I mean, I think that definitely applies even in the non-coding examples. Like I think some of the biggest, like comment from some of the biggest successes that we had in like traditional RAG tools. Okay, well, it turns out like if we just had specific tools to search contracts and contact information,
Yeah,
all of a sudden the agent can now combine them to figure out, who do we need to harass to get something done, and like
yeah.
who's the right person to contact, and say, okay, well, just message the guy's boss instead. Um, and all of a sudden, like your legal workflow becomes a lot more productive.
Yep.
Um, yeah, I guess let me take another look at some of these questions, and as I do that, I'm curious if you have an answer to this question, which is, as people are building these agents these days, what do you think is something that people are not asking themselves as they sort of set forth on this journey?
That's a good question. When I take a look at what other people are doing, I think people that are building in the coding domain, in some sense, are like they see a preview of what is going to roll out to agents in other domains because like coding is such a kind of early use
Hmm.
case of agentic models. And so I think what people in the coding domain more and more so are starting to realize is uh, like how many of the best practices of like the previous AI coding paradigm no longer apply.
Hmm.
And I don't think that message has bled out to other knowledge domains uh,
Mm.
quite yet. And so I still see a lot of people focusing on more on like, workflow construction and stitching that together rather than like true agents and other knowledge
Hmm.
domains. And some of that might be justified because you never know how well this stuff will generalize until you actually go and try it. But if I were working in other domains, I would actually at least be trying the agentic approach. And the good starting point is just build a simple agent yourself. They're not that difficult. It's not like agents aren't magic. It's really just what's the term? It's just like invoking the model in a for loop. Like you can think of
Yeah.
it like that. And sub agents are just like nested for loops in a sense. There's a lot
Hmm.
more that comes from just like applying them and building them in practice. But like that's the basic gist of it. And so I think if you're building with AI and you haven't tried this like agentic tool use thing, I think at the very least you should try it and see how it works and do a spike to see where it gets you.
Yeah. Yeah, that makes sense. I feel like, oftentimes when we host these kinds of sessions, people are asking like, what frameworks do you use? What tools do you use? And almost everyone's answer
Yeah.
has been like, the first agent is 300 lines of code. You just sort of make a tool class, add a for
Yeah.
loop, and you can really see how things break and fail.
Yeah.
You mentioned sort of like inheriting the chatbot uh, assumptions when building these agents. I feel like, and maybe correct me if I'm wrong here, you know, today it is the agent in the sidebar, it's in the CLI. I think some companies are exploring things like background agents. Like, do you
Yeah.
feel like that's generally the correct direction, or is there something even like more interesting that you feel like is underexplored?
I think background agents are very compelling. I think that they're like that's definitely going to be a thing. I tend to think that the way that a lot of folks are approaching it is kind of like too vertically integrated.
Mm.
So like as a developer, I think the truly powerful tools are like simple and composable. So
Yeah.
if you think about the tools that have really like stood the test of time, they're like the Unix tools. It's like, you know,
Hmm.
they do one thing, but that one thing might be actually like pretty complex under the hood, but you know, they're encapsulated in such a way that they're easy to reason about, and then you can compose them and you can deploy them into different environments. And I think that's why like the CLI form factor is so compelling right now. It's like I can use the CLI on my local machine, but I can also deploy it into an arbitrary container where I've done the setup for how that development environment ought to build, because that's often very domain specific. And the more vertically integrated approach, I think, can lead to, in the short term, like a snazzier demo. It's like, oh, here's a cool like a video that I'm going to share out on Twitter of it doing a bunch of things. And look,
Hmm.
it's, drag and drop. But I think in practice, what you see is those solutions end up being brittle because there's a huge diversity of code bases. Like we've seen a huge range of build systems, code base size, mono repo versus
Yeah.
micro repo. And it just gets even weirder the more you move up into like the Fortune 500
Yeah.
and like the code bases that power the world. And so I do think that you can optimize for the Twitter hype. If that's the case, then you build a vertically integrated solution that demos well. But I think the long run, things will tend to pull towards tools that are more composable, more Unixy,
Hmm.
uh, and don't force a set of like very opinionated
Hmm.
choices on the rest of the SDLC.
I see. So maybe in the future I'll expect like a app amp, you know, GitHub action that I can just tag and just sort of get some work done that way.
Yeah, I mean, the beauty of the CLI is that like anyone can create a GitHub action that does that themselves, right? Like
Yeah.
thanks to CLI, you don't have to wait for the first party to do it for you.
Hmm. I think
And
this is a.
and
Oh, go
developers
on.
love to build, right? It's
Yeah.
like the magic thing about agents is like it's not just an end user experience that you can ship to people. It's like, hey, try this in the editor. It's pretty good, but also like you can script with this thing, like put it in a bash script. But I think we're thinking more about ways in which we can make it possible to program agents
Hmm.
using actual like programming language as well. So I don't know. Stay tuned for that.
That's exciting. Maybe we'll wrap up with one more question, actually around billing. Sarab asks, how does the billing work so far? For example, when he has Cloud Max, they use like one API. Because you
Yep.
guys are using tons of different models, how are we thinking about like API usage in like the enterprise?
Yeah, so it's really simple. Like the AMP has a server, and so all the inference for all the different models that we use get routed through that single server endpoint, and then we just record how many tokens you're using against each API. Excuse me. And then we just bill you for the usage of those inference APIs. So it's really simple, very transparent, no kind of like magic underneath the hood. It's just usage-based billing routed through kind of like a single API endpoint.
That makes sense. Yeah, I think also I just find the thread experience to be really interesting. Like I think as I sort of grow my own team, it'll be very cool to sort of see how people are using tools, even give feedback and just say, oh,
Yeah,
I was like seeing how you've been doing this like data science with AI. Here's a couple tips, and
yeah,
into more material. Um, I think that's all. I think most of these other questions are very similar. I guess one other question, maybe just comes back to evals, which is when do you lean on tools versus like the native capabilities of some of these LLM systems, right? I think maybe the example is pointing to something like search,
yeah.
but
Yeah, so actually, I would say like search is not a native capability of any LLM. There's some model providers that provide a search endpoint, which I would just say just use whatever works
mhm,
for you. So I think the thing to recognize is that there are many things that are packaged up as sort of like magic, but actually things are quite simple. Like if you want to use web search, there's you can use Brave Web Search. That's what we use. I think it's what some of the model providers actually use underneath the hood as well. There's other APIs. In terms of like what do we decide to build into build as tools versus just rely on the model to do. Like there's some tools, for instance, that do like deeper thinking, like the Oracle tool. Um,
mhm.
it's really motivated by what the model can't do. So I think if you're building these things, just do the simple thing first, see what the model is capable of, see if you can prompt it in that direction. And then when you hit a wall, that's when there's motivation to build an additional tool or build something fancier.
Right. That makes sense. I definitely have learned a lot about sort of how I should be thinking about these agents, especially in the non-coding workspace. I think by the end, people just come up with a blog post, like everything I learned from from hand code and how to build things. 'Cause I do think,
Yeah.
like one of the things been exploring more is having a smaller tool that helps you find the filters you need to search to pass into the bigger tool. Right? Like
Yeah.
even if you just have like generic document search, maybe I can filter by subdirectories or filter by owners or teams and projects, and
Yep.
building that portfolio of tools makes sense. But having a sub agent do that now feels very obvious, right? Because it is like 15 tool calls that is like burning up your tokens.
Yeah.
Um, Great. I mean, we have like 5 minutes left. If there's anything else you wanted to say, I think you shared your Twitter. Um, but yeah, if you have any other message for the audience, feel free to shoot that off.
I
And
think
otherwise, we'll send some notes in the end.
if you're coding for professionally or on the side, we'd love to hear your feedback from trying AMP out. We built it for professional developers, like I said, from kind of like rethinking things from first principles. But as almost like a side effect, we've seen a lot of people who are more on like the novice end of the spectrum get use out of it as well. And so whatever your level of experience is in building things in code, we'd love to hear from you. Our team is very online and responds to feedback very quickly. And we think that what's motivating for us is just to see it used in the wild and to get that feedback. That's like the dopamine hit for us day to day. And there's so much that's exciting that's changing about how code is written. And we're just eager to be kind of like on the frontier and discovering how agentic coding ought to be done in real time. And so much of that is just like listening to our users and learning from them in terms of like interesting creative ways in which they've discovered they can use this tool.
Great. Thank you so much. We will send the recording and hopefully I'll be able to share with you some of the coding agents that I've been working on through that blog post. I really recommend
Nice.
everyone try that out. It's really mind blowing to see AMP just like create an agent in about 5 minutes.
It's crazy. What a time to be alive.
Yeah, exactly, exactly. Great. Beyang, thank you so much. Thank you everyone else listening. We'll send some follow-ups over email. Take care, everyone.
All right. Thanks.